we need to color four sides of a square with RGB, color red, green, or blue. We call that a square is red or R dominant if two of the sides are red, the remaining are green and blue. Now similarly, if a square is green dominant, that is, we have two sides green and the other one is red and blue. Okay, so with this kind of definition, for a given diagram like this, we have three squares connecting with each other. I have 10 different sizes, and we can color RGB for the size. Now, we try to find total number of ways of coloring the square such that three squares is going to be one each for R dominant, green dominant, and blue dominant. And the order doesn't matter. Could be RGB or BGR, right? The first square is R dominant, the second one could be blue dominant, the third one could be green dominant. Alright, so we need to find the X, which is total number of such coloring schemes. Let's do some analysis. For a given square, if I already have one side colored with red, how do I make the square red dominant or blue dominant, right? So in abstraction, we say, how do I make the square X color dominant when I already colored one side with Y, right? So two cases. One is, what if X equal to Y? In other words, if I have red, I want to make the square red dominant, then we know that we need another red, another green, another blue, RGB each. That would be 3 vectorial, 6 different ways. What if X is not equal to Y? In other words, I have colored R, but I want to make it G, green, dominant. In this case, we need to have two sides with green, and the other side would be blue. So where do you choose blue? There's 3 different ways. Once you choose blue, the sides are fixed. So it's going to be total 3 different ways. Alright? So what if the square, I have two sides colored, right? And with the same color. Let's say in the red. Now if I already colored red, how do I make red dominant, right? Or green dominant, right? Again, in abstraction, how do I make it X dominant if two sides are colored with color Y? Yeah? So if X equal to Y, in other words, in this case, I have already colored red, I want to make it red dominant, then the other two must be green and blue, and there are 2 different ways, either green and blue or blue and green, right? So the total 2 different ways to make it X dominant. What if X is not equal to Y? In other words, I already have colored 2 Y, 2 red, but I want to make green dominant. The answer is impossible. You have 0 ways, because by definition, green dominant means you have 2 greens, the rest is red and blue, but you already have 2 red, so make it impossible. That is 0 ways. Okay, so what if I already colored different colors? Let's say red and green, but I want to make it either red dominant or blue dominant or green dominant, right? So in other words, I already colored 2 different colors, Y and Z. I don't want to make it X dominant, right? What if X is not equal to Y and Z? In this case, I want to make the theme blue dominant. Oh, that's easy. Just color it blue, right? So in other words, there's only one way of doing that. If X is not equal to Y, there's only one way. But if X is one of the Y and Z, for example, if in this case, I want to make it red dominant, I need just pick one red and the other is blue. There's a total 2 different ways. Okay, so with that, so let's do some analysis here. We try to make the square, let's say the first square R dominant, the second square G dominant, the third one blue dominant, RGB in that particular order. How many different ways of achieving this? So let's look at the border here. What is color here? And what is color for the second border here? So we going to enumerate all different cases. What if the color with same color or different color? If the color with red and blue, same color, red, we claim that it's impossible to make it RGB, because in the middle square, you already have 2 red or 2 blue, and you cannot make it green dominant. But if you have two greens, then we know that you can have two ways making the green dominant here, and you have three ways to make red dominant and three ways to make blue dominant here. Okay, now similar analysis, what if this is red and this is blue? If this is red, here you colored one red and you want to make the whole thing red here, dominant here. That is 6 different ways. And B blue here, again make it blue dominant, that's 6 different ways. And here you have R here and B here, blue here, but you want to make it green dominant, so you have to put 2 greens here, so it's only one way, so total 36 ways. Now similarly, if you have blue and red, this is blue, this is red, we claim that there's total 9 different ways. Okay, by using the earlier conclusion, right? We're not going to enumerate all this, but some analysis here is going to show you different ways. When you add it up, is 171. Okay, so in other words, there's 171 ways to make this RGB, but in our original question, the order doesn't really matter. As long as each square is some color dominant, and then one is R, one is G, one is B. There are 6 different ways. Okay, 6 different ways for the RGB dominant, and then each one has 171 ways, so the total is 1026 ways of making the square to be R, G, and B dominant. Okay, that's the answer. Hope you liked the video. Please share and